Hi students, Mrs. Gifford here, and today's lesson is 8.5, Quadratic Equations, Differences of Squares. And after this lesson, you should be able to factor and solve quadratics that are a difference of squares. So let's move on to our what's so special about differences of squares. So let me just see if I can get that slide in there. Sorry about that. So what's so special about difference of squares? Special thing is they're super easy to factor. So we're going to start with this first one, x squared minus 25. And one of the things that we want to think about, and when we talk about this, is we think difference, right? So that's thinking of subtraction. And squares, we want to think of perfect squares. So when I look at this first one of x squared and 25, I know that x squared is a perfect square, and so is 25. And so what we can do is say, all right, well, I know that I can write x squared as x, the quantity of x to the squared, and then minus, and then 25 is 5 squared. Okay, so I'm writing this as what we say as a squared minus b squared. And we can use that same idea then to help us factor that and get our x plus 5 and x minus 5. Notice one of them is going to go here. The other one is going to go in front of the first set of parentheses, and then they each get a 5. And notice that one of them has the plus in the middle, and then the other one has the minus in the middle. That's because when you go the other direction and you double distribute, we need to make sure that we end up with this minus 25 here at the end, and a positive times a negative gives us that negative 25. So knowing that with x squared minus 25, pause the video real quick and see if you can take care of t squared minus 49. Okay, so we're back. Again, we know that t squared is t times t, and 49 is 7 times 7. So we can write that as t to the second power minus 7 squared. And then just like that first example, put them both each in parentheses. One of them gets the plus in the middle, and then the other one gets the minus in the middle. Again, you can check those answers by double distributing, and you'll see that the plain t terms in the middle end up canceling out because they are opposites. All right, moving on. So how do you use the difference of squares to factor? So from here, we're going to take a look at example number 1, 16h squared minus 9a squared. And again, the directions are to factor this polynomial. So again, here's that original equation. And so the first thing, like we just talked about, we're going to write this in the form of a squared minus b squared. So you need to use what you know. First of all, 16 is a perfect square, and so is h. And so we know that 4h quantity squared minus 9 is also a perfect square, and so is a squared. 3 times 3 gives us 9. A times a gives us a squared. And then we're from here. And then just like in the previous slide, once you have them split up into a squared minus b squared, then you are going to factor that difference of squares. So you're going to set up 2 sets of parentheses, and in each set of those parentheses, they're each going to get a 4h, and they're each going to get a 3a. And just like on the previous slide, one of them gets a plus, and one of them gets a minus. So that's 16h squared minus 9a squared in its factored form. Okay, let's do another example. So again, how do you use the difference of squares to factor b to the 4th minus 16? As you're looking at this, again, we're going to write it in the form with our a squared minus b squared, just like we did with the other one. And you need to think back to chapter 7 when we talked about rules of exponents. Well, I know that b squared times b squared gives me b to the 4th. So I've got b squared to the second power minus, I also know that 16 is a perfect square because 4 times 4 gives us 16. So here's our form, a squared minus b squared. And once we've done that, we're going to do our factor of our difference of squares. So just like we did on the previous example, Each parentheses is going to get, one of them is going to get a plus, one of them is going to get a minus. They're each going to get a B. And then they are each going to get a 4. Oops, arrow with the 4. All right, we'll do one more example and then we'll get our summary taken care of. All right, so with this one, if you look at example 3, we're going to use the difference of squares again. And this one's a little bit different. With all the previous ones, we've been able to factor right away because they've been perfect squares. So the next thing that you need to do is factor out, ask yourself, is there a factor that I can take out of here, which we just worked on in previous, in 8.1 and 8.2. I know that I can take a 5 out of both 5 and 45, and I also recognize that they each have an x in there. So the first thing that I recognize is that my GCF is a 5x. And I also want to do that because the whole purpose is to try to get to a difference of squares. And just like we talked about in that last unit, or earlier this chapter, we're going to factor out that 5x. That leaves me with x to the 4th minus 9. If you look carefully, you should notice something within this. We have now created, inside parentheses, we've created that difference of squares here. So we're going to keep this 5x outside, and just like with the previous examples, we are going to write this term, this binomial, in a squared minus b squared form. I know that x squared to the 2nd power is going to give me x to the 4th, and I know that 3 squared is going to give me 9. Then once we do that, then we go to what we just did with the previous 2 examples. Again, I'm going to keep my 5x that I took out before. I'm going to set up my 2 sets of parentheses like I did before. One of them is going to get a plus, one is going to get a minus. They're each going to get an x squared, and they are each going to get a 3. Okay, again, always look for a greatest common factor because the goal is to try to get perfect squares. Once you get those perfect squares and you have subtraction here, then it's pretty straightforward and pretty easy to factor those difference of squares. Okay, so there's our examples. At this point, you should be able to take a look at a polynomial, recognize that it's a difference of squares, and use what you know about perfect squares to get it factored. So take a couple minutes to write your summary. It should be somewhere between 3 and 5 sentences long. Have a good one.